Oh, that song is going to be so stuck in my head now. Okay, well, we're sliding, electric slide. Translations is the name of this transformation. You guys know it as a slide. This is Cusco here. He's just sliding right along. So let's take a look at some of the mathematics behind these translations. So suppose I wanted to take this triangle ABC and just slide it. Not turn or rotate, flip, nothing else. Just slide it over. And maybe I want to take point A, for example, and I want to slide point A to right here. So this will become A prime right here. And every point needs to slide in the exact same distance and direction as that. So that arrow I've drawn could take point B and we could slide it over as well to this point, known as B prime. And then using the same distance and direction, we could move our point C, and its image would be here at C prime. So then just doing a quick little connect up with segments, we've got A prime, B prime, C prime, and join it all up to make the triangle in the image. So what's happened there is every single point has slid in the same distance and direction, and that distance and direction was indicated by this arrow right here. And this arrow is what we call a vector. Now I'd like you to pause the video, and you need to draw that exact same arrow on your paper. And by exactly the same, what I mean is it needs to be exactly the same length and run at exactly the same angle as this one. So pause the video, think about how you would do that, and get one down on your paper. All right, if you have that, you can check yourself to see if you're right. If you took and you count from this beginning point and we just count across, how far across on this horizontal is it? And then a drop down, just building a little right triangle. If you counted and you went 6 across and then you dropped down 2, I'm going to write -2 for that, then you've got the right vector. Now you might not have drawn it in exactly the same location, but you've got the same distance and direction. And that's the way the slide or this translation is run. So we're going to look at vectors a little more closely and some information you'll need to know. First of all, a vector has a notation, usually a lowercase letter with a little arrowhead over it. So like this one that we just saw a picture of over there might be named vector U, and you would just put that on your picture, something like this. And then you can break it down into what's known as the component form, where you're going to look at the first number representing the horizontal change from one point to the other, and the second number, B, here, is the vertical change. That's what we did on this part. So if you were to come across horizontally, count that out, that's going to be the A number, and then dropping down vertically, that's your B number. Those two numbers would go in there. So for example, this vector that we drew here, using those pointy parentheses to indicate it's a vector, that had the components of 6 in the horizontal and -2 on the vertical. And that's how we describe its distance and direction. We've done this, guys, before with some of the Pythagorean theorem work and slope and things like that we've done. So I hope you recognize it and this is pretty easy for you. It's a nice review of some other concepts. So let's take a look at this example. We're going to identify the translation rule, which is otherwise known as the vector, that's going to superimpose this pre-image of Cusco here onto the image. So what we need to know is what's the vector that moves or slides him over. Now the way this is done is you need to locate a point on the pre-image. It can be any point you like. I like this one right here where his fingertip is because it's pretty convenient. And you need to draw a vector. Use a straight edge and draw a vector to the same point in the image. That's the vector that we're looking for. Now we're going to just break that down into some components. So I'm going to just do a count starting at the pre-image. How far across is that? I'm looking at this horizontal count here. It's pretty long, so let me come back and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9 if I did that right. 9 units across to the right. And then there is a drop of 2 units, so indicate that drop with a negative and call it -2. The translation rule would be using capital T to represent a translation according to the vector of 9, -2. And that's a little subscript there, kind of write it smaller. And every single point does that. So you'll notice I can take that same vector, I can move, let's take his toe tips or his heels here, the back of his hair, even his nose tips right there. It's all the same for every point. Which brings us to your foldable. So grab your foldable and let's put some information about the translations in there. Okay, first things first, under a translation, the pre-image is exactly congruent to the image. You're just sliding it, nothing is changing about its shape or size. So that makes it an isometry. We've seen that word before. Isometry means simply that the result image is exactly the same size and shape as the original. They're congruent, pretty much. All right, we specify it by a vector. Now, there's a couple different ways you might see a vector. One way that I just showed in that example is using this capital T and using the component form of A and B to tell the direction that it moves. And on a paper, that would be drawn as an arrow. Now, are there any points that don't move? Of course, if it's a slide, everything's going to move together, so that's a big no. All points move in the same distance and direction. The only changes we see are location. And before we move on, let me jump back on that vector. I think it might be important to note that that A and B stands for the horizontal change and the vertical change just separated out. So A and B. All right, so let's take a look. We're going to find a pattern and call it a mapping rule. We're going to take a translation of this polygon under the vector -7, 2. So rather than draw the vector, I'm just going to start counting points. Let me take point A, and according to the rule, we're going to move 7 units to the left and 2 units up with every point. So counting that out for each one, it'd just be 7 back and 2 up. So here's our A prime. And we want to list that down in our table. That location for A prime is -9, 3. Okay, we're repeating for every point. So taking B prime as another example, back it up 7 units to the left, and then up 2, and label that B prime. And let's note that that's at -5, 4, and put that in our table. All right, you should get the hang of that. I want you to pause the video, do the last 3, C, D, and E, put them in the table. We'll come back and look for a pattern. All right, if you're back with me, you should have the entire pentagon translated, drawn in, and also this list. Check your list, see if you got the same results I got, because now we're going to hunt for a pattern. What you're looking for is how the effect of that vector translation changes your coordinates. So let's start just here with -2 on our x-coordinate that's now become a -9. Think about how that happened. And let's take a look at all the x's and see if there's any pattern going on. So 2 has become a -5 and 4 is -3. What pattern are you seeing in all of these? If you're noticing, like I am, that each one of these is 7 less than it was before, you might write that down this way, that we've subtracted 7 from every x-coordinate to get our new one. Well, that sure looks like a pattern to me. What's happened to the y-coordinates? If you look at 1 that has become a 3 and 2 that's become a 4, there's another 1's become a 3 and so on. What kind of pattern do you see here? I'm seeing they're all 2 bigger. So 2's been added to each one, and it happens for every one of them. Even 0 becomes a 2. So there's a definite pattern here, and it goes right back to this vector. So it looks to me like the vector is being added to all the coordinates of these pre-image points. And that's how we'd write it as a general rule. We're taking our A value, and we're adding it to all the x's. And we're taking our B value and we're adding it to all the y's. Now, the way you write that as a mapping rule is to put down that you've got your original x and y coordinates and they're being transformed. And the way that they're being transformed is just as we said above. X plus A and y plus B. So that can be a nice rule to know. Okay, we get to practice this pattern. So we're going to write a rule that describes the translation. What we need to do is figure out what the vector is. So how does the x change? It's gone from 4 to 5. Well, that would mean I added 1. And now I want to check and see if that's working for all of these. -5 plus 1 does make -4, and 3 plus 1 really makes 4. So that's going to be my horizontal component. On my y's, I see 2 has become -3. That's a drop, so it looks like I subtracted 5. 8 was subtracted to bring it down to 3, and -7 subtracted to bring it down to -12. So we have enough information, and if we want to write the rule, we can write it a few different ways. We can write that it was a translation based on the vector that takes me 1 to the right, and for the vertical, it takes me down 5. So that would be one rule. We could write it in a sentence and say move 1 to the right and 5 down. Or we could write our mapping rule. And our mapping rule would say that all the x's and y's have changed in this way. We've changed them to x plus 1. And what did we add to the y's? Well, we didn't. We subtracted, so y minus 5. All of these are correct. You do need to recognize all the different forms. In this example, our job is to sketch a graph under the translation, and they've given us a mapping rule. So let's study this a little bit. I see I get to take my x's, and how do I change them? X's are staying x. So what's that mean? That means I don't do anything to the x's. So all x's are the same. In other words, we're not going to be moving left or right. We're just going to stay right where we were. However, the y's are being added 5 units to them. So for the y's, we're going to move the y's 5 units up. So it's stay the same on x, but move 5 units up. So we're just going to slide this thing up 5 units. Let's take it one point at a time. Move y, 1, 2, 3, 4, 5. There's y prime. D is going to move 5 up. 1, 2, 3, 4, 5. There's D prime. And K is going to move 5 up. 1, 2, 3, 4, 5. Putting it right here for K prime. Alrighty, we just connect these up then, and we've translated the whole triangle. And that's the translation. So I hope you have a good time. I'll see you in class.